All right, let's dive into something that's at the very core of writing clean code. We're going to explore a pretty counterintuitive idea. What if following the rules, the things we're supposed to do, actually makes our code worse?
Yeah, I know. It's a bold question. I mean, for years we've had these golden rules of software design drilled into us. But what if one of them has this hidden dark side that nobody really talks about? Well, that's exactly what we're getting into today.
And that golden rule? It's, of course, don't repeat yourself, or DRI as we all know it. It's probably one of the very first things you learn as a programmer, right? The idea is super simple. See the same chunk of code in a few different places? You gotta find a way to combine it. Makes sense, right? Totally logical.
Okay, so let's look at a classic example to make this real. Imagine you're building a game. You've got your main character, you've got some enemies, maybe a few, I don't know, pesky obstacles bouncing around. And all of them, every single one, needs to have a position in the world and needs to be rendered on the screen. Now, you could just copy and paste that position and rendering code into every single class, but that just feels wrong, doesn't it? It feels messy.
So what do? We abstract it. I mean, that's the textbook solution, right? We spot that repeated pattern, we yank it out, and we create this one beautiful, neat game object class that handles all that shared logic. And now our character, our enemy, and our obstacle classes can just inherit from it. Boom. Clean, simple, efficient. Problem solved.
And doing this over and over, well, it reinforces this really powerful instinct in us as developers. We start seeing things in black and white. Code repetition, that's bad. More abstraction, that must be good. It just becomes a reflex, an automatic reaction. But this is exactly where the trouble starts.
You see, every action we take in software design has a reaction. And the reaction to abstraction, well, it's sneaky. It's something that doesn't pop up right away, but it can create these massive headaches for you down the line. There's a hidden cost we're not seeing. And this quote just reframes the entire discussion perfectly. The idea is so powerful. For every single bit of abstraction you introduce into your code, you are unavoidably adding something else. And that something else is coupling. You can't have one without the other. They're basically two sides of the exact same coin. So what is coupling exactly? Well, think of it as how tangled up your code is. It's how much different parts of your system depend on each other. So if two things are tightly coupled, changing one of them has a really high chance of breaking the other one. You know that feeling, right? That feeling of dread when you change one tiny line of code and suddenly you have to go fix 10 other files? That is the pain of high coupling. So here's the trade-off we're making. And a lot of the time, we don't even realize we're making it. On one hand, yes, we get less repetition. That's our goal. But the cost is that we're now forcing all these different parts of our system to depend on that one single abstraction. And that makes them so much harder to change independently later on. Okay, so theory is great and all, but let's make this super concrete. We're going to walk through this simple little story, a case study that shows exactly how our good, clean code instincts can lead us straight into what you might call an abstraction trap. All right, here's the setup. Our program currently saves all its data in XML. But, it's time to modernize, so we want to move over to the much nicer JSON format. Now, the smart play here is to create a completely separate new class for the JSON writer. Why? Because that way, when we're finally ready to switch over, we can just delete the old XML class, and we won't have to untangle a bunch of messy, complicated logic. So far, so good, right? This is solid engineering. But then, we notice something. Both our XML saver class and our new JSON saver class, they both take a file name in their constructor. And just like that, ding, 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 our don't repeat yourself alarm bells start going off in our heads. The temptation is just overwhelming. We have to abstract this away, right? But should we? Okay, let's actually stop and analyze this trade-off. What is the benefit? The benefit is we avoid writing one single line of code in each class. That is literally it. Now what's the cost? The cost is we have now permanently shackled both of our savers to the idea of saving to a file. The second we decide, hey, maybe we should save to a database or to a cloud service, our shiny new abstraction completely breaks. The cost is massive and the benefit is tiny. It's just not worth it. Okay, so that was a bad idea. We dodged a bullet. But the temptation, it doesn't stop there. We keep looking. We look at the code that uses these savers and we see that both of them are called with a .save method. Aha, we think. Another repetition. Surely we can create a common save interface for them, right?
Let's run the numbers again. What's the trade-off? By creating an interface, maybe we can remove one duplicate line of code somewhere else where the .save method is called. That's the whole benefit. And in exchange, we are now forcing both of these completely separate classes to have the exact same save method signature forever. We've just increased their coupling, made them less independent, all for almost zero practical gain. It's another bad deal. So here's the crucial takeaway from this whole story. After looking at both of those temptations, the correct engineering decision is to do nothing. Absolutely nothing. Just let them be two separate, distinct classes that have no connection to each other at all. That tiny bit of repetition is so much better than creating a fragile, totally unnecessary abstraction that just ties them together. Now, look, this doesn't mean abstraction is always bad. Of course not. That's not what I'm saying. It's an absolutely essential tool in our toolbox. The whole key is knowing when to use it. So let's switch gears and figure out how to build a better intuition for this. Turns out there are two really clear signals that tell you when the cost of coupling is actually worth paying. Basically, an abstraction is worth it when you need to separate the decision of what to do from the action of doing it. So what does that mean? Well, think about scenario 1. What if you're not just adding a JSON saver, but also a database saver and a cloud saver and a bunch of others? Okay, now an abstraction is super useful to help manage all that complexity. Or scenario 2, what if the action needs to happen at a different time? Like say you have an interval saver that just saves every 5 minutes. That thing shouldn't have to know or care which specific saver it's using. In these cases, see, the abstraction is actually doing real valuable work for us. So what this all means is that we can't just blindly follow "don't repeat yourself" like it's a command. We need something more nuanced, a smarter golden rule. And that new rule is this: stop thinking in absolutes and start thinking in trade-offs. And here it is. This is the new mental model you should have. From now on, before you create any abstraction, you have to stop and ask yourself one simple question. Does the value this thing brings, in terms of flexibility or managing complexity, does it truly outweigh the cost of the coupling I'm about to create? Sometimes the answer will be a clear yes, but as we just saw, a lot of times it's a big, fat no. And that brings us to our final and maybe most critical takeaway. Really let this one sink in, okay? When you're looking at the future of your project, all the changes, all the maintenance, a little bit of code repetition is often way less painful to deal with than a tightly coupled system that's built on a premature or just plain unnecessary abstraction. So, what do you think? Maybe it's time we all re-evaluated our relationship with the "don't repeat yourself" principle. Take a look at your own code base. Can you find a place where a little bit of repetition might actually be the cleaner, simpler solution? It's definitely something to think about.